People wonder how a coding agent can jump into a new large repository and fix something, all of that with minimal instructions. It feels like it already understands the code base. Matter of fact, it doesn't. It starts very simply with one or a few strategic keywords and then explores the repository step by step until it finds the right information, the right place to make the change. Suppose the user asks, how does this app send email? It starts with the keyword email. It uses this tool called Ripgrep. This is the workhorse of the exploration detective work. So first casts a wide net with the keyword email, searches for files that mention it. There are a bunch of files that it finds recursively across the repository. Ripgrep is an extended grep which is extremely scalable and does recursively and respects git ignore. So it finds that mailer.py looks like the core file and maybe it should look deeper into it. That's its guess or assumption with which it moves forward. In the next step, it inspects the core file, the mailer.py. It doesn't look at the whole of it. It tries to get a more fine-grained view of the file by looking for def and the line numbers we mentioned def. These are the function definitions in Python. So it gets these three functions that are defined in mailer.py. So reading these names supports its assumption that this is indeed the file where the mail is sent, and it concludes that send email looks like the one that is most relevant. But we haven't read the whole function, so we can't be sure. So let's first look into it. So that's the next assumption. Look into send email, and to read that email, to read that function, again expands the content, and luckily it finds that the SMTP lib library is used. So it concludes that it uses the Python built-in SMT lib and reads the host from settings. That essentially gives it an idea of where the mailing code lies. And it could conclude with search at this point, but it tries to be comprehensive and also tries to figure out who calls this function. More details about the callers of this function and the settings. So to find, it looks for this keyword send email with a bracket. That's where the callers are. And interestingly, both the callers are inside the same file. So the two other functions both call this function and to send email. So it includes that it's only called within mailer.py. This confirms that the wrappers are the public API of send email. This is now very clear, and we also have a slightly broader understanding of how email works in this repository. And to verify with some more context, it cross-checks that the settings file indeed has these SMT configuration parameters. So the config is read from environment providers with localhost fallbacks. There's no third-party SDK, it's pure SMTP. Okay, so we gain some more broader understanding. So all of this is done just with RG. You can go back and start with email keyword, look into functions, slightly deeper, then very fine-grained, read the details of the function, find SMTP, look for callers, and verify that the config has all the information. There's no other code involved. So that completes its investigation, and it's ready to answer. The email is sent via Python's SMT lib, configured through environment vars. Public API has two wrapper functions, which internally calls send email. Nothing outside mailer.py touches send email directly. So this is quite comprehensive. Starting from just the email keyword, it's able to localize the relevant parts of the code and gain a deeper understanding of how mailing works in this data. So that is the loop: broad search, read, inspect, and extract sharper keyword, and repeat the process. The tool creates a small map around the query using essentially two operations: localization of code, iterative localization, and inspecting at different levels of resolution. These two operations help it build a map and navigate down to the most relevant parts. We saw how the magic works, but there are several assumptions that actually made this magic work. So let's look again. Let's review that again. It searched for email. There are several files, but it zeroed in on mailer.py. Okay, so that was a key assumption. It could have also chosen to look into test mirror first, which would have distracted it a little bit. So that's the key assumption that worked, and search involves making several such assumptions. Some of them might be wrong. The other part is when it chose to read this file. Ripgrep allows you to expand a window up to a particular length. So this number 8 was enough to figure out that mail is sent with SMTP. It would have to make a retry and expand it more to read that function in full detail. So that's other assumption. There are other ways to use the AST to navigate better through several other optimizations. For example, our code agent could fire the same queries over and over again, leading to a lot of tokens being wasted. Instead, they build what they call a code map, which they can directly refer, they build incrementally and directly look up to find dependencies directly. Not just keyword search, which RG does very effectively, semantic search using vectors, finding similar code to a keyword or key phrase. That is a useful optimization for some cases where the exact keywords are not the bridge between. There are no exact keywords that bridge the query with the actual. So that's a quick overview of the coding agents. I've also written an article about it. I'll point to it in the comments. The effectiveness of such coding agents which do iterative localization and inspection has spilled over to other domains, and as one of the biggest domains that is agentic search, where you can search arbitrary documents using similar principles as opposed to traditional vector embeddings. And I'll talk more about that in other videos.